Good morning students. In the previous video lectures we have discussed about the instruction sets of 8085 microprocessor. Now in this video lecture we will discuss about the addressing modes of 8085. We know that the 8085 can access data stored in different parts of the memory using instructions. But how the data is accessed is what is known as an addressing mode. To make things simple, let us imagine a colony of warehouse of uniform size in a grid formation. Each warehouse has a number allotted to it, which is called its address. Also assume that each warehouse has some goods in it. This will be our data, and every house and the goods stored in it are referred to using the address. The grid shown here or below will help you to visualize it. Also, there are some special warehouses in the colony which have special names allotted to them. These represent our registers B, C, D, E, H and L, and they are organized in pairs. Here is a visual representation of the registers in 8085. Some other registers such as program status word, stack pointer are not shown here. While writing an assembly program for 8085, we will use various ways to access data stored in the memory and the register. These are called addressing modes. All this may seem a little intriguing in the beginning, but the example and code snippets along the way and the analogy used here will enable you to visualize everything. Or the different modes of addressing that data stored in memory. Let us look at each of them one by one to get a clear picture. Implicit addressing mode. In this mode, the number directly given by the programmer is moved into the location specified. This location would be a register or an address in the memory. It would be easy to understand through the following example. Move immediate A, 25H. It is an immediate addressing mode. From the name itself, we can say that immediately data is being moved here. Move immediate A, 25H. The 25H data, hexadecimal data is immediately loaded in the accumulator. Move immediate C, 62H. So in this statement, we are directly giving a number 25H and telling the microprocessor to move into the accumulator register. So using the analogy discussed in the starting, you can understand this is as telling the microprocessor, hey, take this goods, that is number 25H, and store it in the warehouse with name A. In other words, we can understand the immediate addressing mode as a mode in which an immediate value is given to operate on. Notice the operands of LXI instruction or register pairs. Stack pointer register whose combined capacity is of 2 bytes, that is 16 bits, and hence we can give a 16-bit number as a second operand. If we give a 8-bit number, the higher byte are assumed to be 00. Here are some more examples of the instruction which uses immediate addressing mode. There are some more instructions that uses the immediate addressing mode. All such instructions are also being listed. These instructions may seems to be too many, but you can simply remember them as the instruction ending with I. The instruction ending with I, which stands for immediate addressing or immediate addressing mode, with one expectation through the jump instruction. So jump instruction is the only instruction which is a immediate addressed instruction which does not contain I. All other instructions which ends with I are nothing but of immediate addressing mode. Next, register addressing mode. In this mode, the data to be accessed and operated upon is present in the register and is accessed by specifying the name of the register. For example, move A, B. So the content of source register B is being moved to the accumulator register. since the operation is happening between the registers, it is being called as register addressing mode. This command moves the content stored in the B register to accumulator. In terms of analogy used above, consider that the beside the warehouse having number as address. Some special warehouses also have names, and in this mode we use the name of warehouse. The above example can be imagined as telling the microprocessor, hey, I want the goods stored in the warehouse with the name B to be moved to the warehouse with the name A. Here are some more examples of register addressing mode. Some more instructions using register addressing mode are given below. To know about each of them in detail, you can check the previous video lecture on instruction sets of 8085. Consider the grid of warehouse we discussed in the beginning. The warehouse had number as addressed. In this mode, that is in this direct addressing mode, we use the corresponding number to refer the warehouse, that is memory location. In other words, we access the data stored in the memory location using its address. Consider the example. The first line tells the microprocessor, load the content of the memory location with the address 2034 into the accumulator. In order to understand the second line in the example better using the analogy of warehouse, this instruction can be imagined as telling the microprocessor, hey, I am giving this address 2040 to you. Go to the warehouse at this address. Pick the content stored there and load them into the warehouse with the name L, that is register L. After that, go to the next address 2041 and transfer it content to register H. Here are some more examples to understand the direct addressing mode. Next, we will discuss about register indirect addressing mode. In register indirect addressing mode, now this one is a little tricky to get, but can be easily understood using the analogy we used in the beginning. In this mode, the registers hold the address of location from which the data is to be retrieved. Confused? Consider the following example. Move A, right? So here the content in the memory location is being moved to the accumulator, right? You also see this program, right? What I have written over here. So what will be the accumulator, what will be the content of accumulator after this code is being executed? Any guesses? Yes, register A will hold the value 25H and that will be stored at the location 2030, right? So after I will explain the program now. After the execution of first line, the register H will be having a value of 20H stored in it, and after the execution of second line, the register L will have the value of 30H stored in it. So now we are having 2030 stored in the HL register path. The instruction in the third line tells the microprocessor to look at the address 2030 and load the content stored there into accumulator. As we assumed that the memory location with address 2030 is being loaded with the number 25H, which is being stored previously in that particular address location. So the microprocessor will copy it and paste it in the accumulator, and hence the accumulator will contain 25H. In the fourth line of instruction, we tell the microprocessor to move the value given by us, that is 92H, to the memory location, and the address of memory location, that is 2030, will be loaded with this 92H. So at the end of this program, the accumulator will be holding a value of 25H and the memory location 2030 will be holding a value of 92H. Here are some more instructions which uses the same mode of addressing. Next, implied addressing mode. In this mode of addressing, the microprocessor already knows the location of data to process and the program does not need to define it explicitly. That information is already contained in the opcode. For example, the first instruction CMA complements the bits. Using our analogy, we can say that the instruction complement tells the microprocessor go to the warehouse with the name A, access the content stored. The content will be a packed 8-bit, unpack those bits, complete each bit one by one, complement each bit one by one. If one bit is 1, make it 0 and vice versa. Then put those bits in their corresponding position, repack them and put them back in the warehouse A. Right? The address of data to be manipulated is the register A, which is not stated in the instruction. It is already understood by the microprocessor when such instructions are used. The second example, RLC, is explained through the picture. To get a more in-depth explanation of how this instruction works, you can check out the previous video on instruction set of 8085. To have a more clear picture and a better understanding of implied addressing mode and CMA and RLC instruction, read the code which I have written here. Let me explain now. In the first line, the value 07H is stored in the accumulator. The 8-bit representation of 07 is 4 zeros followed by means of 0, 111. In the second line, the bits are rotated left in a circular manner. So the bit stored in A becomes as 4 zeros followed by means of 1110. Note that each bit is moved left by one position and the most significant bit is moved to the least significant bit position. The same operation is repeated and the value stored in the accumulator changes to 0001 1100. The same operand is repeated third time and the value stored in accumulator changes to 0011 1000. The same operand is repeated and the value stored in accumulator changes to 0111 followed by means of 4 zeros. This value in hexadecimal is 70H. So by means of rotating 4 times, 07 has become 70 now. Now in the sixth line, all the bits in the accumulator are complemented. So 70 which is being holded in the accumulator is now complemented. So we will be getting an answer of 1000 followed by means of 41. Before complementing, the accumulator holded a value of 70. Its binary equivalent is 0111 followed by means of 40. If we complement 0111 followed by means of 40, we will be getting 1000 followed by means of 41. Its equivalent hexa code is 8F. 100 is of 8 and 41 its equivalent is of F. So 8F is being now stored in the accumulator. At the end of the execution of this program, the accumulator will be holding a value of 8F. When at the beginning of the program execution, the accumulator holded a value of 07, but at the end it is holding 8F now.